Lesson 3.2, Solving Inequalities by Adding or Subtracting. So in this section, there's not many definitions. Actually, there's none. So we're just going to get straight into some examples here where we're going to be solving inequalities and also graphing the solutions. So let's look at this first example here. We have s plus 1 is less than or equal to 10. So with this, we first need to solve the inequality by getting the variable s on the left side all by itself. So we have to take the inverse of plus 1 to get s all by itself. The inverse of 1 is minus 1. So the opposite of adding is subtracting 1 from the left side, subtracting 1 from the right side. So then I have on the left s is less than or equal to 10 minus 1, which is going to give me 9. So I've solved for the inequality, but now I need to graph. So here's where we set up our number line. And if s is less than or equal to 9, if it's less than or equal to, it's going to be a closed circle at 9 because it's including 9. And the variable s is less than. Remember, when it's less, you shade to the left. So this is my graph for that problem. Example number 2, we have 2.5 is greater than negative 3 plus t. So here we have to get t all by itself. So I'm going to add 3, take the inverse of a minus 3, which is adding 3 to the left and to the right side. Negative 3 and positive 3 cancel out, which leaves me t on the right. On the left, 2.5 plus 3 is going to give me 5.5. So my solution to this inequality is 5.5 is greater than t. So now let's graph this solution. I know my graphs are not the straightest lines, but when you are doing this on your homework, I do want you using straight lines with a ruler. So if 5.5 is greater than t, notice 5.5 is not included. So I'll find 5.5 on my graph. Here it is, 5.5. I will have an open circle at 5.5. 5.5 is greater than t, so t is actually going to be less than 5.5, so I'm going to shade to the left. So another way of looking at this is if I look at my variable t, how is my inequality sign? How does it look facing t? Notice it's less than facing t than the 5.5, so that's how I know to shade it to the left as well. So t is any number that is less than 5.5 to make that a true inequality. Here we have example 3. Again, we're solving these inequalities and graphing the solutions. We have q minus 3.5 is less than 7.5. We need to get q by itself, so I'm going to add 3.5 to the left, adding 3.5 to the right. So what I have on the left is q, which is less than 7.5 plus 3.5 is going to give me 11. So when I solve for this, q is less than 11. So if I draw a straight line for my graph, q less than 11, I do not include 11, so I have an open circle at 11. Q is less than, so I'm going to shade again to the left with my arrow, so q can be any number less than 11. Example number 4, we have 9/10 is greater than or equal to n minus 3/10. So I need to get n by itself by adding 0.3 to both sides, or 3/10. 9/10 plus 3/10 is going to give me 1.2, which is greater than or equal to n. So now I need to graph that. 1.2 is going to be closer to 1. There it is, 1.2. So 1.2 is greater than or equal to n, so it's going to be a shaded in circle there at 1.2. And since n is less than or equal to 1.2, or 1.2 is greater than or equal to n, again here I'm going to shade to the left. And there is my graph for that situation. The next two examples you're going to see are story problems. So for this story problem, it says Sammy has a gift card. She has already used $14 of the total value, which was $30. So she used $30, or she had $30 and used 14 of that $30. They want us to write, solve, and graph an inequality to show how much more she can spend. So we have to think of writing an inequality based on this situation. So if she's used $14 out of the total 30 and they want to know how much more she can use, we'll have 14 plus G. We'll call G as representing how much more she can use, which is going to be less than or equal to my total $30. So 30 is my max. So let's find out what G can be to make this situation true. So I'm going to subtract 14 to each side. So what I have left here is G is less than or equal to 30 minus 14 is going to give me $16. So she has $16 more to spend on the gift card to max out to her value of $30. So now let's graph this. So since G is less than or equal to 16, I'm going to have a closed circle at 16. G is less than that, so I'm going to shade to the left. And that is my answer. So I've wrote the inequality, that's the first step. I've solved it, that is my second step. And then I've graphed it, which is my third step. So you need to make sure that you're showing all of those steps in the bookwork as well with story problems. Last story problem here, Mrs. Lawrence wants to buy an antique bracelet at an auction. She is willing to bid no more than $550. So far the highest bid was $475. Write, solve, and graph an inequality to determine the amount Mrs. Lawrence can add to the bid. So let's set this up. If she can bid no more than $550, that means she can bid $550 or less. And so far the highest bid was $475. So this was what they've had so far. This is what they can bid up to, is no more than $550. So let's write an inequality based on this. So if they've already bid $475 plus a variable, we can call this X, is going to be less than or equal to my highest bid I can bid up to, which is $550. So let's find our variable X. So let's subtract 475 from the left, subtract 475 from the right. So I solve by having X is less than or equal to 75. So now I need to graph that. So X is less than or equal to 75. I'm going to have a shaded in circle at 75, and I'm going to shade to the left because my variable X is less than or equal to that. And that is my answer.